Okay, my name is Lucy Lovely. I teach 9 through 12 at Jackson Independent School, really small school, graduating class of usually about 19, 20, so super small. When I was approached about this particular, trying to come up with an activity, I've been teaching, this is my 17th year, and I always want something that fits into life science. I go to so many meetings where there's a lot of physical science, a lot of chemistry, so I definitely want something that fits with the biology. I'm also very intrigued by microbiology, and I incorporate that into several of my classes. So one of the classes where we do a lot of micro, obviously, is in biology with the quality core. And some of the things that we do, and I've got my standards up here, but obviously just looking at cells, knowing the diversity of cells, osmosis. Right now I'm on osmosis, and you can actually use this to look at like Elodea plant cells. You can do salt water, watch the cells shrink. You can do a lot of stuff with that. When you're studying tissues and organs, they have to know the difference between epithelial, connective, muscle, and nervous tissues. So even though a lot of people just skip right through that in biology, that's something that I really like to emphasize. So there's a lot of places where you can incorporate this at the cellular level into biology. I also use it in advanced biology. Advanced biology at my school, we actually study the different kingdoms of life. And so when we're on our unit on viruses and bacteria, we can use it with bacteria. We can use it with protozoa. If you want to watch a paramecium actually feeding or something to that level, and there's so many ways to do this. And so when these kids get to college, sometimes they just don't get enough micro practice. Sometimes kids start college, they don't even know how to work a microscope, more or less a Bunsen burner. And so this gives them the opportunity to learn how to do that. Now the issue with it is that they often use it incorrectly. So teachers will go into a class and already have the microscope set up for them, and all they have to do is view and sketch or something like that. So this way I can actually see where they're like, everything looks the same. Am I looking at water? Am I looking at dust? And so this allows me to see what are they doing wrong. It's kind of like doing a math problem. You need to watch them do it to figure out what they're doing wrong. So I wanted to incorporate something that involved tech, because that's going to be the future. And so I worked with my tech person, and I kind of thought that this would be a really good idea. Now, this type of equipment's been used for a long time, but it keeps getting better and better. You can hook a digital microscope to a camera, project it on the TV. That's been going on for a long time. But these are just amazing. Everything's high def. You can video live streaming. You can do screenshots and make PowerPoints with that, and it's a lot of fun. So I'm just now learning the equipment because it just came in last week. But what I did, if anybody teaches at this level and likes to work with microscopes and has iPads, so this is a good way for them to learn microscope technique. That's just a bonus. And then they actually get a look at cells. You could actually do this with younger grade levels, I think, that, you could start out with prepared slides and say, let's learn how to use a microscope first. And let me see what you're seeing. And because they don't know. And then, the old-fashioned way was, let's take turns. You look, I'll look. But now you can do it together. And you can save those images, which they'll like maybe to show their parents, and you can use it as quick formative assessment. So basically, what I've got here is I couldn't afford to have a full classroom of them, but you've got the student microscopes, and you can see on this little flyer I gave you, and there's a couple spelling errors, so please disregard that. It should say live video images. So there's two different ones. The student microscopes, they just attach to the ocular lens through the eyepiece, and basically there's a Wi-Fi code on the actual instrument on this little piece right here. And so you will have to also upload an app, which took us a while to figure out which one it is, but I actually put it on there. I'm not even sure how to pronounce that, like soup, maybe Toop View, but that's the one that we figured out through troubleshooting that worked best. So you log on to the Wi-Fi, which connects to the digital microscope, upload this app, and the images are on the actual iPad. It's awesome. It's really neat. So we practiced getting that set up, and I'm in the process. I actually got 5 of those, but eventually I'd like to have more because I know all the students are going to want to use them. And then the second thing was a new digital microscope for myself. This one is a little bit better. It does live video and recording, so I underlined the recording there. There's a little mouse that comes with it, and so you can actually record what you're seeing. And so, which I think would be good if I got, it's really hard to get a paramecium, for example, doing something really cool. So if I wanted to record while I did it, then I could actually show that next year. I mean, there's YouTube, clips of stuff like that too, but, this is, if I could find it, that's really cool. So I can record. The only problem with this was a troubleshooting issue as well. Most of these, as you can see in the picture, have a different lens in the back for digital microscopes, and I just had the one ocular lens. So the teacher one required an extra adapter, and I put requires a 0.5x reduction lens to fit into the ocular lens. So, there are some issues we're kind of working through, but I think the kids will really like it. They love doing stuff, anything hands-on. And with the microscopes, hopefully that's going to help them with testing, and, all that good stuff. You guys have any questions for me?